So now we will discuss about the minimization of deterministic finite automata. Up to now we have discussed epsilon NFA to the NFA, NFA to the DFA, and directly from epsilon NFA to the DFA in the last sessions. So in this session we will discuss the minimization of deterministic finite automata using the two ways. First one, we can minimize this DFA using the equivalence theorem, and one more way, we can also minimize the DFA using Myhill-Nerode theorem. Both are important. So first we will discuss one by one. First we will discuss using the equivalence theorem how we will minimize our DFA. Here I have taken the DFA diagram. So you can look at the carefully because it is the deterministic finite automata. From the single input alphabet we have the single transition itself. So from Q0 we have A and B. We don't have another one more alphabets. So from Q1 we have Q1 and input alphabet A and B. First we will see the transition table, so that we will simply go with the theorem. States on input alphabet A and B. So first we will have the states Q0, Q1, Q2, Q3, Q4. Q0 on input alphabet A, the transition to the Q1. Q0 on input alphabet B, we have the transition to the Q2. Q1 on input alphabet A, the transition to the same state itself, that is Q1. Look at the arrow marks. Q1 on input alphabet B, so that is we are reaching to the Q3. Q2, coming to the Q2 state, Q2 on input alphabet we are reaching to Q1. So on input alphabet B, the same state itself, that is Q2. Q3 on input alphabet A, we are reaching to Q1 here, the transition. So Q3 on input alphabet B, so reaching to Q4. Q4 on input alphabet A, we are reaching to Q1. From Q4 on input alphabet B, the next state is Q2. This is our transition table. So according to the given DFA. Now we will see what is the equivalence theorem. So first we will make it as based on the partition technique. So first we will go with the partition. Coming to the given DFA, we have the final state and the non-final state. We will partition the final state as one state and the non-final state as the one more state. First we will see the partition, first P0. So what are the non-final states we have? Q0, Q1, Q2, Q3. The final state is only Q4. Whenever we have the double circle, we will get to know that it is the final state. This is the P0. Non-final states and the final state we have done the partition. Now we will compare these states with the other input alphabets. First we will see one by one. We will see from Q0 and Q1. So we will see the transitions, delta of Q0 comma A, delta of Q1 comma A. On the first input alphabet A, we have taken Q0 on input alphabet A. The next state is Q1. Q1 on input alphabet A, the next state is Q1 itself. Both are in the same state, that is Q1 in the same state. So again check for the B also. Delta of Q0 comma B, that is Q2. Delta of Q1 comma B, that is Q3. Again check it, Q2 and Q3 both are in the same state, right? So Q0, Q1 are in the same state. Now check Q0 and Q2. Delta of Q0 comma A, delta of Q2 comma A. So delta of Q0 comma A, that is Q1. Again delta of Q2 comma A is also the Q1. Both are in the same state. Next check the input alphabet B. Delta of Q0 comma B, delta of Q2 comma B. Delta of Q0 comma B is on Q2. Q2 comma B is also the Q2, both are in same state. Okay, that means Q0, Q2 is also in the same state. Now check it. Q0 and Q3. Delta of Q0 comma A, delta of Q3 comma A. Compare. So Q0 comma A, that is on Q1. Q3 comma A, that is in Q1. Both are same state. Delta of Q0 comma B. Q0 comma B is Q2. Q3 comma B, that is in Q4. Now check the comparison. Q1 and Q1 are both in the same state. Q2, Q4. Q2 is in the non-final state. Q4 is in the final state. So one transition is in the final state. One transition is the non-final state. That means both are not in the same state. That means Q2 and Q4 both are in the different state. That means whenever we are comparing with Q3, that means Q3 is also the different state. That means we can make one more partition, that is P1. So that means Q3 we are dividing from this partition, because whenever we are comparing with the Q3, so we have reached to the different states. That means Q3 is not in this partition. So Q0, Q1, Q2 is one partition. Now move Q3 to the another state, because whenever we are performing with Q3, we have reached to Q2 and Q4. Q2 and Q4 are in the different states. Now move this Q3 to the different state, and Q4 as usual, that is the final state. Now after doing one more partition, now again compare Q0, Q1, Q2, both are in the same state or not. So let's compare. So delta of Q0, Q1. Q0, Q1 we are comparing here. Q0 on input alphabet A, Q1, Q1 on input alphabet Q1. Both are in the same state. Okay. Next Q0, Q3. So Q0, Q1 on input alphabet B, Q2, Q3. Coming to here, Q2, Q3 are in the different states. That means write down one more comparison. Delta of Q0 comma B, delta of Q1 comma B. Whenever you are doing this, Q0 comma B we have the state Q2, Q1 comma we have the state Q3. Now after the new partition, Q2 and Q3 are in the different states. So now whenever we are comparing with the Q1, so we have reached to the different states. So now let's Q1 is in the another partition. That means P2, that is one more partition. Go with the Q0, Q2 is the same. Q1, whenever we are performing the Q1, we have reached a different state, that is Q2 and Q3, right? So making Q1 as the one more state. So remaining Q3, Q4 are the as it is. Now again compare Q0, Q2. So now Q0, Q2, compare Q0 and Q2. So Q0 on input alphabet A, Q1, Q2 on input alphabet A, Q1, both are same. So Q0 on input alphabet B, Q2, Q2 on input alphabet B, Q2, both are same. That means Q0, Q2 are in the same state, because we have reached to the same states. Q1, Q3, Q4 are the different states. Like that we have done our partition. So first partition we have taken is as the 9 final states and the final states. Next partition, whenever we reach to the different partitions, we have taken it as the different partition technique. Next we have taken so different state, because Q0, Q2. So whenever we are performing the Q1 as the different one, so we have make it the Q1 as the different state. Now we have reached to the all the states. Now draw the minimized DFA. That means Q0, Q2 are the same states. Q1, Q3, Q4 are the different states. That means Q1, Q3, Q4 is the different states. So we know that Q4 is the final state. Now draw our DFA. So from Q0 to A, Q0 to A we have Q1, Q0 to B we have Q2. So that means we have Q0 to B, that is Q2 means we have to write the self state. Next Q1 on input alphabet A, Q1. Q1 on input alphabet A, Q1 on input alphabet B, Q3. Next Q2 on input alphabet A, Q2 on input alphabet A, Q1, already we reached this same. Q2 on input alphabet B, Q2. Q2 on input alphabet B, Q2. Already we reached the same because Q0 and Q1 are the same. Next Q3. Q3 on input alphabet A, Q1. Q3 on input alphabet B, Q4. Next Q4 on input alphabet A, that is reaching to Q1. Q4 on input alphabet B, Q2. So Q4 on input alphabet B, that is to Q2. This is the minimized DFA diagram. This is our the resultant DFA. First, what we have done? This is our given DFA. We have written the transition table and we have make the partition. So whenever we have reached the different state, we have done the partition. So at last we reached the partition technique, that is P2. We have stopped. We don't have Q0, Q2. We are in the same state. We reached to the same state. So we have stopped the process. That means here Q0, Q2 is in one state. Q1, Q3, Q4 are the different states. Like that we have drawn our minimized DFA.